Hey everyone, Mr. Vance here. Today we are going to talk about ratios. So with a ratio, say it's less of a problem and more of an idea that we can use to apply to a lot of different things. And what a ratio is just essentially just one thing compared to or in reference to another thing, another quantity, another amount. So we can write these in a number of ways. We can do this as a measure of just sort of like 2 over 3, some sort of like division symbol, right? This thing on top is compared to this thing on bottom. We can do it with a colon. We can go like 2 colon 3 like that. Or we can even just write it out. We can just say 2 to 3, right? This many things compared to that thing. Now these don't have to be just entirely raw numbers or things just in the abstract that we're talking about, although these are very useful when we are talking about, say, the measurements of a room or an object. We can also use these in reference, sort of one object in reference to another. So let's say I have some fruit. Let's actually do something simple. Let's do some shapes. So I'm going to have a circle, and I'll have another circle. Let's go ahead and have 3 circles. And then let's do 1 square. Let's make it a blue square. Okay? So my ratio of circles to squares is 3 to 1 right here. I'd say 3 to 1, but let's go ahead just to make it even more clear. All right, our 3 there is red, just like our circles. The ratio here is 3 to 1. And once we have this sort of simplified form, the ratio allows us to scale things up, to increase the numbers, to make sure that we have the same mixture, right? The same amount in comparison to one another. So right here I only have 3 circles in 1 square, but maybe I want to increase the number of squares or circles that we have, or both of them. So let's say I go ahead and give myself 3 more circles. Let's make it transparent here. Okay. So now to keep the ratio of circles to squares equal, I have to add another square, right? And now this would be, we would say that the total number is now 6 to 2. But if you remember what we've talked about with simplifying fractions, right? 6 to 2 can be simplified down to 3 to 1. Right? And that's because the ratio is going to be the simplest form of a fraction, an equation, right? And by having this sort of magical smallest number, we can scale things up higher and shrink things down. And if we just want to keep the comparison the same, this compared to that the same, then we can do that, right? So let's go ahead and talk about some examples where we might use this. So let's say that you are mixing some trail mix. I do love me some trail mix. And most trail mix is going to have kind of like 3 things. You're going to have sort of your nuts, like peanuts. We'll go ahead and do peanuts for now. Oops. And then you're going to have usually like your raisins or some other fruit. There's a lot of different ways to make trail mix, but we'll keep it traditional today. And usually some sort of chocolate bit. We'll just say M&Ms for now. But, chocolate chips would be common too. And usually the ratio of these things is like skewed actually in this sort of way that I wrote them out too. Like you usually have the most peanuts followed by a higher amount of raisins, and then usually the least amount of M&Ms, as long as you're keeping to a reasonably healthy trail mix. So let's say that I'm making a trail mix, and we'll do 3 cups of peanuts, and then we'll do 2 cups of raisins, and I'll give myself a little more space here. 1 cup of M&Ms. Okay, that's what I made my first time. That's my ratio here, or the amounts that I chose. Now we could make ratios with them. Like if I said, if I had a question here, like what's the ratio of peanuts to raisins? Well, that is going to be, we have 3 cups of peanuts to 2 cups of raisins. And so our ratio would be 3 to 2, right? And you could write this again, you can write 3 and over 2, like that. You'll have to forgive me, I'm doing this all in Microsoft Paint. It's not exactly the world's nicest program, but we're going to get there. Right, so we could write it like that as well. And it just means the same thing. It's just a different way of writing it. Right? But for every 3 peanuts we have, 2 raisins. And now say, let's say we want to scale this up. I'm having a party, and I need to increase this recipe by 5. I have so many people coming over, and it's just a trail mix party, so we're going to eat a ton of trail mix. So how do I scale this up? Well, as long as I stick to my original ratios, the ratio of peanuts to raisins and the ratio of the raisins to the M&Ms, then as long as I increase all these amounts by the same amount, right? So if I double all of them together, all of their amounts, then the final trail mix bowl that I have is going to be the same mixture, right? I'm not going to have way more peanuts than I am raisins or M&Ms by just increasing the amount, as long as I do it all the same. So here's how we're going to do that. Let's say, again, I want to make this same amount, we'll say times 5 or x5. So the way that I would do that then is we're going to take our 3 and our 2 and our 1, 3 cups of peanuts, 2 cups of raisins, 1 cup of M&Ms, and I'm going to multiply all of these by 5, right? I need to make this whole mixture just 5 times bigger. So right here, we'll do I'll go ahead and write it out. My writing's a little bit nicer here. We'll make it a little smaller. So I would say we have 3 times 5 right there. This 2 is going to be multiplied by 5, and then this 1 is going to be multiplied by 5. So you could write this straight across, or you can kind of do what I'm doing right here, which is where you just sort of times 5. And then maybe down in parenthesis below, I might write really small. We'll just kind of write, okay, well, 3 times 5, so that's 15. And then 2 times 5, I'll do a comma to equally divide it out. 2 times 5 is going to be 10. And then for our M&Ms, 1 times 5 is 5. So, as long as we're doing cups, so the final amount of, I guess we'll call it, ingredients I will need to make this 5 times bigger is 15 cups. We're going to keep the same unit of measurement here, right? 3 cups is now 15 cups of peanuts, 10 cups of raisins, I don't know why it's capitalized, raisins, and 5 cups of M&Ms. And that's it. There's just so many different ways that you can use ratios, right? And like, for example, another thing I could have done is I could have compared the amount of peanuts to the total amount of food I have here, right? So if I had 3 cups of peanuts compared to 3, 4, 5, 6 cups of trail mix, It also could then tell you that the peanuts are 1/2 of the trail mix, right? So you can use these things in a lot of ways, and we're going to use this idea a lot as we go forward. Remember, finally, I'll do this some last tips right here. One is to keep everything as a mixed, or not a mixed, but rather a improper fraction. I almost said faction. An improper fraction. So even if we had something like 3:1, we wouldn't actually want to write it as 3. We're going to keep all of our ratios as something over something else, or something divided by something else, because we're comparing. It's 3:1 or 3:7, something like that. Yeah, go ahead and keep that idea in mind. We're going to keep building on this as we go forward. But yeah, I hope this helps you. Thank you so much for watching, and I'll see you later.